Wheatstone bridge. An important application of Kirchhoff's rule is the Wheatstone bridge. It is used in electrical network to compare resistances and in determining the unknown resistance. Physics for Everyone welcomes you. We derive balancing condition for Wheatstone bridge, that is P by Q equals R by S. Next, by using this Wheatstone bridge, we will measure the unknown resistance. Next, we will be checking out what are the different forms of Wheatstone bridge. The bridge consists of 4 resistances P, Q, R and S connected as shown in the figure. A galvanometer G is connected between the points B and D. Between B and D, there is a galvanometer. The battery is connected between the points A and C. And there is a current setup. The current through the galvanometer is Ig and its resistance is G. Right? The current through P is I1, current through Q is I3, the current through R is I2 and current through S is I4. The galvanometer has a needle which deflects when current passes through it. The needle deflects towards left when current passes in one direction. Now the current goes from B to D. So the deflection is towards left. Check out the needle. Good. And towards right when the current is reversed. Now the current goes from D to B. The current is reversed. Now check out the needle. It gets deflected towards right. The bridge is said to be balanced when current through the galvanometer is 0. When will it happen? When the potential at B and potential at D are same. Then the potential difference between B and D equals 0. Then no current flows through galvanometer. So Ig equals 0. When Ig equals 0, what happens? I3 equals to I1 because I1 is not splitting up into two current. I1 equals I3. I3 equals I1. No branch at B. The same way, the current I2 as it is flows through S because no incoming current from B to D. So I4 equals I2. Let us prove these two, I3 equals I1 and I4 equals I2 by using Kirchhoff's current rule. Kirchhoff's current rule at junction B. Look at junction B. I1 is coming towards B, so it is given positive sign. Then Ig is going away from junction B, it is given negative sign. I3 is going away from junction B, so I3 is given negative sign. So the algebraic sum of all these three current equals 0 according to Kirchhoff's current rule. As Ig equals 0, then I1 equals I3. It has been already told. Then next, let us look at the junction D and apply current rule. At D, the current I2 is coming towards D, so it is given positive sign. Then Ig is coming towards D, so it is given positive sign. Then I4 is going away from junction D, so it is given negative sign. So the algebraic sum of all these three current equals to 0 according to current rule. As we know, Ig equal to 0, I2 equals I4. Let us apply KVR to loop A, B, D, A. We have to take what is the direction of traversal. Let us consider the clockwise direction is the direction of traversal. I1P is given positive sign because the current I1 is in the direction of traversal, so I1P is positive. IgG is given positive sign because the Ig current is along the direction of traversal. I2R is given negative sign because the direction of I2 is opposite to the direction of traversal. So I2R equals is negative, right? Equals the total EMF, that is 0 because there is no EMF in this closed path. As we know Ig equals 0, we can come to conclusion I1P equals I2R. Let us go for the next loop and apply KVR. B, C, D, B. B, C, D, B. We have to still follow the same direction of traversal. Clockwise is positive. I3Q is positive because I3 is in the direction of traversal. Then I4S is negative because I4 is in the direction of, I4 is in the direction opposite to the direction of traversal. So I4S is negative. Then IgG is negative because Ig is in the direction opposite to the direction of traversal, equals 0. So Ig is 0. So I3Q equals I4S. Now this I3 value equals I1 value. I3 equals I1, right? The same way I4 equals I2. So we replace I3 and I4 by I1 and I2 respectively. So we get I1Q equals I2S, right? This is the equation number 1 and this is the equation number 2. Let us divide 1 by 2. We get P by Q equals R by S. P by Q equals R by S is the balancing condition for Wheatstone network. To measure unknown resistance, let P be the resistance to be measured. Then Q is the adjustable resistance. R and S are the known resistance. The Q is the adjustable resistance. Right, good. The value of Q is adjusted so that the deflection in the galvanometer becomes 0. So Ig equals 0. Then we can apply P by Q equals R by S. From this equation, we can get P equals R by S Q. Different forms of Wheatstone bridge. The left hand side you have the reference diagram and the right hand side as the modified diagram. So in the modified diagram, right, the EMF, the battery replaces the galvanometer and the galvanometer replaces the battery. Good. Cells and galvanometer arms are interchangeable. The balancing condition remains the same, P by Q equals R by S. This is BD arm. B and D junction goes to A via P and R respectively. B and D junction goes to C via Q and S. And between the junction A and C, you have the battery. So this is another modified form of Wheatstone bridge. Here you have the arm BD. Now the junction B and D goes to A via P and R. The junction B and D now goes to C via S and Q. Now between A and C you have the battery. This is another modified form of Wheatstone bridge. The same Wheatstone bridge but in the form of circle. It's in another form. Thank you, children.